Today we are going to learn a new topic, that is joining processes. This topic is 8 marks for our exam. Joining processes. This is the 5th chapter of our subject. See, this is the syllabus of our topic. First point, that is welding processes. In this welding process we are going to learn gas welding, about carbon arc welding, shielded metal arc welding, TIG welding, MIG welding, plasma arc welding, resistance welding, and their types: spot, seam and projection, electron beam welding, laser beam welding, and their welding defects also we are going to see in this topic. The second point is introduction to soldering and brazing. In this point we are going to learn about processes, fillers, heating methods and applications. So let's start. Welding. What is welding? Welding is a metallurgical fusion process where parts to be joined by the application of heat and pressure. It is used to join the two different parts. It is commonly used in the industries. Why we use welding? Because where we want to join two parts, that time we require welding, and this is mostly used in industrial area. Advantages of welding: it is used for repair work. This welding is used for repairing work. The strength of joint is good. They have high corrosion resistance. Welding is used for floor tight joints. Different types of joints can be done. Welding is economical and cost efficient. Disadvantages of welding: it is produce harmful radiations. It produces internal stresses, distortions and change in microstructure in welding region. Previous preparation requires skilled operators. For doing this welding process, there is a requirement that the operator should be good and skilled in their work. Applications of welding in automobile parts, aircraft and ship constructions, machine frames, pipelines, tanks and vessels. There is also some standards. The standards are contained in ASME. There in that standards there are some clauses. With the help of that clauses we follow the standards. Welding process is categorized as follows: fusion category, pressure welding. In fusion category there is a gas welding, arc welding, other welding processes are there. In gas welding there is oxyacetylene welding. Other welding processes: electron beam welding, laser beam welding. In arc welding there is carbon arc, metal arc, tungsten arc. It means tungsten means TIG welding, and another is plasma arc welding. In other welding processes we are going to learn about electron beam welding, laser beam welding. In pressure welding there is a resistance welding, spot welding, seam welding and projection welding. First of all, we are going to see about acetylene gas. In this process, oxygen and acetylene gas is used for welding processes. It rises the temperature of metal above melting point. Filler metal is used for joining. With the help of acetylene gas, we use filler metal to join that the part. Operation. In this process, oxygen and acetylene is used for the welding. Oxygen supports the combustion and acetylene gas generate high temperature. Why we use acetylene gas? Because of their high temperature rate. Operation starts with placing the part together, which is to be joined. Acetylene flame heat the metal temperature produced about 3200 degrees Celsius. Filler material is copper coated steel, carbon steel. Welding processes is as shown in figure. Advantages: it is used for all types of joints. Oxyacetylene flame can be easily controlled, suitable for thin metal sheets. Equipment is portable and versatile. Limitations of welding process: method is slow, distortion of workpiece is more. In this diagram, there is a direction of travel is here, filler rod is here, base metal, welding torch tip, flame, mixture, solidified weld metal, molten weld metal. Types of flame. First, natural flame. Second is reducing flame. Third is oxidizing flame. In natural flame, all gas is burned. Gives 100% heat. Ideal flame used in gas welding. In reducing flame, it consists of inner core, intermediate feather and outer flame. It is also called carburizing flame. Strong reduction in higher zone due to high amount of acetylene. Third is oxidizing flame. In oxidizing flame, it contains more oxygen than any other flame. Contents of oxygen is more in oxidizing flame. This is used for oxidizing metal like brass, zinc, etc. It is similar to natural flame. Arc welding. In this process, heat generation takes place by an electric arc. Both workpiece and electrode is connected to different terminals of AC or DC supply. Small gap between workpiece and electrode arc is generated. It produces temperature about 3600 degrees Celsius. It having following types: carbon arc welding, shielded metal arc welding, gas shielded arc welding, plasma arc welding. Carbon arc welding. It is a new welding process. Electric is made of carbon. Electrics are soft and not suitable for high temperature. Electric consumption slowly and requires filler material. Arc is generated between electrode and workpiece. DC supply is used. Electrode is negative and workpiece is positive. It is used for thick material. Carbon arc welding is only used for thick material. This is the diagram of carbon arc welding. Here arc flame is here, filler rod is here, slag, this is the slag, deposited metal, work, this is the workpiece, arc core, arc steam, carbon, electrode is here. Shielded metal arc. In this, electric arc is for the welding purpose. Flux coated electrode is used for the welding. Flux gives stability to protection to weld metal. During welding, electrode is made and serve as filler material. flux over the electrode is also get melt to form coating over the weld material. Advantages of shielded metal arc: simple process. This is a very simple process. Welding equipments are portable and less costly. This is less costly, and these equipments are portable. Metal and alloy can be welded. Applicable in any position. Disadvantages of shielded metal arc: automatic welding is difficult because of short electrode. Process is slow. Welding defects are more during replacement of electrode. This is the diagram of shielded metal arc welding. Base metal is here, molten weld metal, solidified weld metal, slag is here. This is the slag. Electrode coating is here. Consumable electrode, direction of travel of this electrode rod, protection gas from electrode coating. Tungsten inert gas welding. It is also called as tungsten arc welding. In short, we can say that TIG welding. Inert gas is act as shield and keep content away from welded metal. Electrode does not melt during welding. It is non-consumable electrode, filler material added separately. Inert gas is argon. Inert gas is used for this process is argon. Advantages: slag-free operation due to absence of flux. Different materials can be welded. No cleaning requires. Disadvantage of this TIG welding is equipment cost is high, slow process, filler material requires. Gas which is used through the nozzle. Filler rod is here. Metal droplet is here. Direction of welding is here. Current which is supplied. Gas. This is the tungsten, gas shielding, and arc welding. Metal inert gas welding, that is called GMAW. It is also known as gas metal arc welding. In this process, weld joint is brushed by hitting the metal with electric arc. The filling wire is continuously fed from wire reel at constant rate. Wire is fed through the rollers at constant rate. Instead of flux, inert gas is supplied through welding torch. Welding torch is connected to cylinder of very gas like argon. Advantages: slag inclusion are not occurs. Continuous feed makes process faster. Less skilled operator is required. There is no need to skilled operator. Less skilled also we can use. He can also handle the welding. Thick sheets can be welded. This is the diagram of metal inert gas welding. This is the nozzle. Electro wire is a shielding gas is a direction of travel. Shielding gas fed from spool. Base metal and molten weld metal. Disadvantages: process is complicated, setup is complicated, initial cost is high. Application for welding of commercial metals like nickel, steel. Plasma arc welding is here. This is tungsten electrode. Direction of travel is here. Plasma stream is here. Base metal. This is molten weld. This is shielding gas is here. Shielding gas passes through this area. Plasma arc. This is plasma arc. In plasma arc welding, plasma is heated. Ionized gas enable it to conduct electric current. Plasma arc is narrow, restricted electric arc passes through water cooler orifice. It consists of non-consumable tungsten electrode and shielding gas like argon. Argon gas flows through the orifice to form plasma. The temperature of plasma is about 10,000 degrees Celsius. Temperature of plasma is about 10,000 degrees Celsius. Advantages of plasma arc welding: weld uniform throughout. Weld is uniform. Greater depth of welding with less distortion. Proper control on heat. Metal disposition rate is high. Limitations: welding equipments are expensive, frequent replacement of nozzle. Application: stainless steel welding, nickel alloy in aeroflame, aluminum or graphite nozzles for rocket. Resistance: in this process, heat and pressure is applied on joint. No additional filler or flux material required. Heavy current heat joint up to plastic state. It is classified as spot welding, seam welding, projection welding, offset welding. Spot welding is shown in this picture. This is the electrode. Weld nugget is here. Sheet metal. This is sheet metal. Electrode is here. Force is applied upward direction and downward direction. Current, this is the positive, negative current is here. It is the first type of resistance welding and widely used for lap joint of thin metal sheet. It consists of two electrodes in which bottom electrode is fixed and upper is used for applied pressure. Upper is used for only pressure and bottom electrode is used. It is a fixed. Sheets to be weld are kept in the two electrode. The pressure is applied over the sheets and current is passed through it so that they get weld. Welding is done due to high current is passed through the metal plates which produce heat. Current passes through the metal plates, so heat is generated. Applications: for mass production for ferrous and non-ferrous metals used to weld sheets of 10 mm thick. This is seam welding. Sheet metals parts shown in figure. Electrode wheel is here and motion of parts are shown in the figure. It is used for special purpose. In this process, disc type electrodes are used. Discs are rotated continuously so that metal sheets move forward. Current can be regulated by timer to produce continuous seam. Applications of seam welding is as shown. Seam welding and sheet metal parts as shown in this diagram. This is the electrode wheel and motion of parts past wheel is shown in this diagram. And applications of this seam welding is for gas or water tight joints to manufacture seam welded pipes. Projection welding: this is the electrode, sheet metal parts are here. Projection: this is the projection. This is the force upward. This is upward force. Weld nugget is here. This is the weld nugget. It is modification of spot welding. In this type, one of the sheet is provided with projections and other is plane. These projections are in circular form. Diameter is equal to thickness of plate. During this process, welded sheets are kept between electrodes, which is made of copper. Pressure is applied by upper movable electrode and lower is fixed. By passing current, these projections get melted and welding is done. This is the soldering. This is a filler metal. With the help of this filler metal, we can do soldering. About soldering, only filler metal is melted, not base metal. Base metal is not melted, only filler metal is melted. Lower temperature than वेल्डिंग पेक्षा हे टेम्परेचर कसं असतं कमी असतं. फिलर मेटल डिस्ट्रीब्युटेड बाय कॅपिलरी ॲक्शन. मेटलर्जिकल बॉन्ड फॉर्म्ड बिटवीन फिलर अँड बेस मेटल. काय होतं मेटलर्जिकल बॉन्ड फॉर्म होतं त्यामध्ये. स्ट्रेंथ ऑफ जॉईंट टिपिकली स्ट्रॉंगर दॅन फिलर मेटल इटसेल्फ, weaker than base metal. Gap at joint important. Pros and cons: can join dissimilar metal, less heat, can join thinner sections related to welding, excessive heat during service can weaken joint. It is mostly used in PCBs to joints small parts in PCB. This is soldering iron solder wire. This is the solder wire, and this is soldering iron. Hitting lead and placing solder. This is the lead. We hit the lead with the help of solder. Heat for 2 to 3 seconds. Place wire opposite iron. Trim excess lead. This is the trim excess lead shown in the diagram.